So what happens is that, I work extensively on connected products. It is still very new in the market, but people have not really seen connected products except for mobile phones probably. But I am working on very innovative, very interesting products that are slowly entering the market. And even in India, we have seen water purifiers which are connected. We are seeing cars which are connected. We are talking about air purifiers which are connected, health bands which are connected. Amazing stuff. All of them are connected. And what happens is that you get all this data. You get all this data into one nice place, what we call as cloud nowadays. And interestingly, what happens is that all this data comes and sits there, and at the end of the day, it's all pure mathematics. You are talking about what is the air quality in a particular location. Say I have 100 purifiers sitting in the Delhi Dwarka area today. I need to know what is the quality of air. I'll have to take the data from multiple places in Dwarka, and I will be doing some kind of an arithmetic on it, and that is what I use, right? So it is never, it is statistics. It is statistics. It is probability. When I start predicting the quality of data, it becomes probability for me. When I start talking about um, uh, taking decisions based on that data, it becomes artificial intelligence, and that is nothing but prediction, right? It all boils down to prediction. And today everybody talks about, every startup wants to do something in machine learning. Every other startup wants to say that they are doing incorporating artificial intelligence. Very simple, guys, mathematics. And that's all. That also is very, very simple mathematics. Especially in machine learning, when you start thinking about it, it's very complex when you start looking at algorithms, what is going to do and all that. But if you understand the mechanics behind it, it is fairly simple. So the way a machine learns is probability, right? I show, for example, you take, yesterday I was talking to a very large retail company in Asia, and this guy wants to understand whether the store shelf has the products that the customers want or not. So the solution would be that, you just go and fill it up. But he wants to put a camera there and make sure that whenever the customer walks by, he has that product, or he or she has that product there. The way I have to do it is, I have to capture the image, compare it with my database of images, and say that, okay, this shelf is full, this shelf is having, say, a packet of pasta or not. And the way the machine learns this is by comparing um, uh, uh, earlier, you standard image, and then it takes a real-time image, and then it starts comparing. When I say comparing, it takes points from this image, and then starts superimposing with the image that it knows, and sees what is the probability of those points matching. If the probability of those points matching is very high, then it means it's the same. Then I know that, okay, the images are the same, and if this image is pasta, and that image is also pasta. So I'm simplifying this whole process in a very extremely simplifying the process. But algorithm, at the end of the day, does this. It looks at the probability and says that, okay, there's a very high probability that there is pasta on the shelf or not. So as I begin by saying that, I always wish that I learned mathematics better. As I hope I was better, and that's why I could do all those academic credentials that Arun was mentioning about. But it is on one side, as school students, right? Mathematics is fun. Mathematics is very, very relevant, funny. I wouldn't call funny, but it's a fun subject to learn. And even though it looks very intimidating, that once you start applying that and comparing that in your real world, you will start loving it more. It is that is what I felt about mathematics. I set syllabus for some of the engineering colleges in India, and when I talk about mathematics content for them, I always tell them to prioritize the application of mathematics. That is an entirely different area of study when you go into the, college or university. But applied mathematics is a very, very cool theory, cool thing that will make you understand the reason or the importance of mathematics, right? On the other side, the theoretical mathematics is what drives physics and astronomy and all the space stuff that we do today. It is extremely interesting. When Mangalyaan was launched, the whole world was looking at us and saying that how could you achieve something of such great grand magnitude with so less money, right? And our engineers and our scientists in ISRO said that, you guys were trying to fill your rockets with fuel and pushing it to Mars. Instead, what we figured out is that we calculated what would be the path of Earth and the path of Mars, and we found out when we should launch this rocket at what time and what angle and what path, so that it can leverage the Earth's spin. The Earth is spinning all the time, right, from east to west or west to east. So we figured out that we would use that energy to propel ourselves away from Earth into a path that will reach Mars. And that one single idea saved literally millions and millions of dollars and also, when I say we not only saved the money, but it also reduced the complexity of the engines that had to push or propel the rocket to Mangalyaan to Mars, and that single thing increased the probability of success. Amazing idea. And the way it is done is we are really good at theoretical maths. That's all. We know how fast the Earth is spinning. We know at what angle I should launch, so that I could reach the path that would lead me to reach Mars. When the Mars comes around the sun at that particular point, we know when it was coming through. Amazing. The whole thing is so fascinating for me that it's beyond my it's beyond my understanding how they did it, but it is so fascinating for me that these guys are so good in mathematics. I could just go on and tell you stories and stories about how this works in real world. And culturally, Indians are so good in mathematics. There are people who are afraid of mathematics today. Individually, sometimes we feel very intimidated by the numbers, but I would just take one example and then I will move on to just say that, to show how good we are at mathematics, right? So there is this temple in Madurai, a small town in or city in south called Madurai, and they have a huge temple called the Meenakshi Amman temple. Not for any religious reasons, but the beauty of this temple is that it is built almost 1,000 years back, and the way it has been built is that on a new moon day, the full moon day, when this moon is full and it comes up, the rays of the moon, they have made window in the tower of the main cobra, what do you say? They made a window, and the moon's light falls and shines on the idol's nose ring. The nose ring is made of an emerald, and the emerald shines on. And this happens every month, and it's been happening every month for the past 1,000 years. Never it goes wrong. And which just tells us that our ancestors 1,000 years back, whoever designed that building, knew how the celestial objects were positioned, and they knew how light rays will fall on Earth on that particular day, and they were able to exactly place the idol in such a way that the rays will fall on the nose ring of the goddess. Taking away the religious part, this is an amazing piece of mathematics in action, right? So it's a great subject. So let's go ahead and see what all it can do for our lives, right? So it is one of the oldest one. No questions about it. We are the ones who found or invented zero. Zero was not at all known to Western countries, and we are the ones who first invented it, right? I just spoke about how important it is in a scientific world. I just told you how it is important in business world, and when I'm doing this, environment or climate monitoring, engineering, huge structures, your bridges, even your car, your cycle, nothing moves or nothing could have been made without mathematics being the driver for it. And economics, I don't even have to get into it. It's all numbers at the end of the day, right? So it's very important. The subject is very important. What I want to actually tell you is that it is more fun than what you thought. So whenever I think about, or whenever I see 314 anywhere, I always know that it is 3.14. I mean, it's so simple. Whenever I see number plates in the cars, I always try to figure out whether, there's so much of relationship between the 4 digits in the car numbers or bike numbers, whatever, right? So it is also easy to remember if you start making relationships with these numbers. At 5335, instantly you know that the plate is completely made of odd numbers. There are a couple of important prime numbers there, etc., etc. So the moment you start relating these functions and looking at the numbers, it's just 10 digits, right, over 0 to 9, and the amount of impact that it has on our lives, it is amazing. And then you start making algorithms out of it. Algorithm is nothing but how do you structure these numbers in such a way that you achieve certain outputs. If you apply probability, that's an algorithm in a way. If any formula that you apply is an algorithm at the lowest level, and then slowly as you build on it, it becomes more complex, like in neural networks, for example. Neural networks or machine learning, how it does, it's a bunch of small mathematical functions. There are only 4 mathematical functions that we know, right? Those 4 mathematical functions, and then it changes the world for us, right? When you look at a computer, right? A computer has a processor. Every computer has a processor, right? The computer cannot do multiplication. A computer cannot do division. All it does is add and subtract. So with addition and subtraction is what your mobile phones, your laptops, your tablets, even your TV, whatever you use, your electronics with electronics with any kind of software that is there in the world is built based on those 2 arithmetic logic operations. So let's go ahead, Arun. So what are these areas, right? I spoke about probability and statistics, how important it is for any kind of climate analysis or environments that we are looking at. I'll go one by one, actually. Theoretical map, the foundation is what you learn in your school, your algebra, your trigonometry. They actually are the foundational aspects of mathematics. The reason why we want to talk about mathematics in this space is because A sound signal, for example, has to be modeled. You hear sound, you hear music, it is beautiful, but do you also know that music is only mathematics? There are two ways of learning music. One, you learn how to sing, you understand the tones, you know how to play a instrument. But if you closely look at any instrument, or even when you're singing, when you're trying to understand music or learn music, there are only 8 octaves that we talk about. It is fully mathematics. There are thousands of ragas, they say. These octaves and thousands of ragas, how does it come? It is coming only from those 7 swaras, right? Sa, ri, ga, ma, pa, tha, ni, sa. So the way these combine and the way you arrange these sarigama patanisa becomes n number of ragas for you. The way you sing, the way from where you start, the way you arrange these sarigama, it is purely mathematics. I mean, I can actually talk a lot about this because I've listened to Carnatic music. I've listened to the Western music. I've looked at the Beethovens of the world, and when you start looking at it, right, it is just these 7 levels of songs. The 7 levels of octaves. In different cultures, they call it as in different names, but it is pure mathematics. It is pure. They know that if this is the sequence that you're looking at, the next should be this only. If it automatically comes to you in your mind, then you are gifted. But for people like me, it is numbers. I know that after this number, only this number should come. Hence, the music has to be like that. And if you start breaking down any kind of music, it will follow a certain set of mathematical rules. Right? So that is mathematics. Now, how do I use it in real world, right? How do I make my music system play that? How do I make my laptop play that? The laptop understands your music as numbers. It will break it down. We sometimes do transformations on that. When I say transformations, since the laptop cannot understand a continuity, right? So mathematics is, we call it as a continuity from 0 to infinity. And there are millions in infinite number of numbers. From 0 to 1, again there is infinite numbers. It's a very continuous sequence. It's 0.1, 0.2, 0.3. Then you will say that you can break it down saying that 0.001, and so you can break it down to any number of levels. So but then your laptop cannot process that much amount of data. So what it does is it transforms that into a different domain. It again mathematics. Once you move this from one domain to another domain, it is easier for the laptop to understand it and process it, and that is how it processes it. So that would come under what you call as numeric analysis or computer algebra. So that every single thing that you see, the music is a great example. I love listening to music. I'm sure a lot of people would know. And sometimes when you start listening to this music, right, as school kids, school students, you will be listening to a lot of music. And I would actually suggest, why K-pop is so popular. Why do you like K-pop, by the way? You don't even understand Korean, probably. Some people may understand, but people like me, I don't understand. I listen to K-pop. I listen to Italian songs. The reason is because in your brain can understand the sequences. Consciously or unconsciously, it will understand the sequences. Everybody's brain will understand sequences. It understands music. And the reason is, yes, it is very catchy. You know why? Your brain loves that sequence. If a particular sequence of Sarigama is there, the same sequence will be available in Italian music also. The same amount sequence is available in any language that you will see. So they say that music has no language. That the reason is because your brain understands that this sequence is a peppy sequence. I enjoy it. And there is a lot of chemical reactions that go in your brain. That's a different topic. But your brain understands these things. Sometimes it is conscious, sometimes it is not conscious. Even it is not conscious, you will not be able to explain why you like it, but in any language it is the same, right? I'll touch upon operational research a little bit, because that is another subject that everybody would encounter. You will speak about it, think about it, people will talk about as you go into your college and university levels. The reason, so operational research is essentially, I'll explain that with an example, right? You have trains, and then you have your train bookings. Once upon a time, we used to do this train bookings on IRCTC website, and I started analyzing, because that one particular train which I always wanted to use, wanted to take to, I was not getting the tickets that easily. So I used to try various combinations. Okay, let me try it on a weekday, weekend, morning train, evening train, and so many combinations. And then I said, okay, let me figure out this. So I downloaded a lot of data about that particular train's bookings, and I started analyzing what is the right time for me to book that ticket, and I will always get the ticket, which means that I need to figure out when people don't travel in that train most. It is an interesting problem. I didn't have to do complicated mathematical analysis on it. I just had to look at huge amount of data. Wednesdays, what is the capacity, or what is the booking status on Wednesdays? What is the booking state on Thursdays? And so on and so on. And I was able to arrive at a solution saying that if I book it on a Monday 5 p.m. train, I'll be able to get tickets most easily, right? So this is not very complicated. Anyone can do it as long as you have that data. So this is one of the operational research problems, right? Another problem that I tried analyzing is how much time does it take for a queue to move? It's a very common problem, and this is applied in most of the applications across the industries. How much time does it take for a queue to move? The queue will have hundreds of parameters affecting it. You start looking how much time people take to process it, depending on what process it is. Maybe it is a bank teller who's counting money and giving it. The time taken for him to enter that into the system, verify the challan, verify the person, etc., etc. And then you come out and say that, okay, these are the ways I could influence the ticket, influence the queue speed. When you pick up your phone nowadays on IVRs, it will always, in many IVRs, most advanced ones actually say that you are third in the queue. How does it know that it is third in the queue? What if the second guy is going to take half an hour to talk? Sometimes they will say that you're in the queue and you will be attended within 3 minutes. When they say 3 minutes, you feel that, okay, it's just 3 minutes, I'll wait. Or if they say that you're third in the queue, you don't feel like waiting there, because the second guy can take 30 minutes to finish. So, or he may even finish in 1 minute. So that is what is operational research is about. The operational research gives you a lot of tools, boiling down to very simple facts of mathematics, to say how to apply, how to solve real-time problems. Geometry extended to is what gets extended to astronomy at some level, right? And another thing, rate of change of derivatives, integrals, these are all applied in mechanical industry primarily, to design engines, and also to program your computers. So as I said, computer does not understand mathematics as well, or it cannot handle numbers as much as we can do. And so we come up with various methods of doing that. So So those are called transformations. You will learn a lot of transformations later. You a very simple thing that I could say is that you have your speaker at home, talks, it just vibrates and gives you nice music. The speaker, if it vibrates without control, it will break down. If there is a drum sound that needs to come out, and then the speaker starts vibrating, and if you do not know when to stop vibrating, it will never stop. I mean, as long as there is energy, it will continue to vibrate, and it will not be music anymore. So the mathematics is required to understand whether that particular system will be stable or not. So we call it as stability, and mathematics is what will help you to model those situations, right? So where is it used, right? It's used everywhere. It is used most in technology industries. Like I'm from technology industry, right? So I can do connected products. I know exactly where it works. Every single thing that I see in my day-to-day life needs amazing amount of understanding of mathematics to know to make things work. Financial industry. When I say in financial industry, the most common thing that comes up is stock markets, right? Stock markets is filled with so much of mathematics that you can actually go to NSE website or BSE website and pick up any stock, and then you start seeing analysis on it. There are a number of theories that will predict. It's all prediction. Everybody wants to predict what will be the price of the next the stock in the next minute or next day, and so on. So it is huge, hugely used in the stock markets. It is also used in analyzing companies financials. Suppose I have to invest into a company, or if I want to see how my company is going to grow, or whether how much my company needs money, how much money my company needs to operate. Everything boils down to understanding mathematics. Most important area that I would like to point out today, coming from technology industry, is that we don't have enough people who understand maths, basic probability, basic statistics, basic prediction theories. Fibonacci series is there. 1, 3, 5, and so on. 1, 2, 3, 5, and so on. Right now, it's already defined. What if it's not defined? How do I predict what is the next number? I don't have people who understand that. And it is very, very important, because a lot of applications that we do in today's software industry is built on what we call as artificial intelligence and machine learning. And for that, people need to understand mathematics, right? People need to understand statistics. People need to understand probabilistic theories. Now we have multiple courses that incorporates mathematics as a part of it. There are courses which are fully mathematics oriented. Somebody with BSc statistics or MSc statistics is very hard to come nowadays, come by. There are a lot of tools available from Microsoft and Amazon and even Google, helping people to apply these components. We are talking about number of things here, right? Sampling distributions and statistical inferences, quantitative analysis, probability theory. All these have multiple what I would say theories or formulae that is applied in different applications. Can I apply one theory in a particular application? Maybe not. What's the difference between a normal distribution and a Gaussian distribution? Maybe it's the same. For somebody like me, it is the same. But then I cannot apply that both of them in a particular situation, because maybe my sample set is less. People need to know, if I apply normal distribution in a particular situation with X amount of data or sample points, whether I will get the right output or not. Otherwise, the whole prediction that I do will be wrong. We use this for a lot of line fitting, right? We've come across a lot of line fitting algorithms with data points. When we do that, if you don't have enough data points, the line fitting will be completely wrong. The moment your line fitting is completely wrong, you cannot predict what comes next. And your prediction, if your prediction is wrong, then it could have really bad consequences in the real-time world. For example, you have these autonomous cars nowadays. How does it know that it is going to crash somewhere? Because it knows that this is the path that I'm taking, and the next point where I will be is on this path. If the whole path is calculated in a wrong way, then I'll go and crash. It boils down to that. So this is where the topics listed down here is very important. I would think that anyone with BSc Maths or BSc Statistics, the core understanding of mathematics will be able to apply that in real world situations, and the jobs in this area is huge. You will have to also understand how to apply in real world. Maybe you should understand how you should pick up computer programming skills. Most probably Python is taught along with these courses in most universities nowadays. There is a good tool called R, MATLAB. These are all tools which will help you to apply these theories in real world. Which of these theories that you should, which of these formulas that you should apply in real world? What is the application of that? What kind of application will need which kind of algorithm or formula or concept is something that we need to understand. So you could take any of these. If you're inclined towards finance, I would say pick up economics or commerce. Finance and economics is completely different, but then it will help you in the job market. Mathematics and statistics, if you're keen on artificial intelligence and machine learning, combined with BSc Maths and statistics combined with computer science, will help you to pick up roles in any of these artificial intelligence or machine learning applications. BTech is building products, right? It has a little bit of maths here, a little bit of computers, a little bit of hardware. It's a bunch of a number of number of areas coming together, but that gives you an overall view of how things work. And when I studied BTech, and now when I see what we do in the market and what I expect out of BTech people, I think the world has also become very complicated. It's not just computer science, or it's not just electronics nowadays. It's not about communication. So what happens is that I also need to understand a little bit of thermodynamics. I need to understand a little bit of civil engineering, for example. So that rounded view of world or applications is very important. So if you take any one of these as your next step, always supplement with what is required in the industry later. If you are interested in finance, the first three plus some amount of computer science. If you're keen on artificial intelligence and machine learning or neural networks, mathematics and statistics, even robotics, right? Robotics will need mathematics and science, statistics. BTech will give you an overall view of how to build this. It will not make you an expert in any of these areas, but it will give you an overall idea of how to build products, how to think, and how to make build businesses. Actuaries is one of the highest paid jobs right now, right? It needs huge amount of understanding of mathematics, and the job is actually very tough, I can tell you. Actuary is what? It is analyzing or calculating the value of human life. So what actuaries generally do is they help insurance companies to model the risk. If I give a policy to this guy is going to pay me, say, 1 lakh rupees and take a 1 crore policy. And if this guy dies tomorrow, I have to pay him 1 crore, right? So how do I ensure that this guy how do I know that this guy will not die tomorrow? If he dies 50 years later, I'm fine, because every year is going to give me 1 lakh, and I'll make up that money. But if he dies tomorrow, then I have to pay him, right? So that is what insurance is about. And actuaries help insurance companies to calculate this risk. There's a number of parameters that will come into it. Even I do not know about it, but it is essentially analyzing all that data about age, what is his habits, what the kind of stress that he has, what is his health parameters, etc., and then come back with a risk probability saying that, okay, there's very less chance that this guy will die in the next 50 years. Then I give him the policy. So that is what an actuary does, and it is very, very highly paid job, I think, overall in the financial industry. All right, let's try to go to the next slide. Okay. Next slide. Economists. Economists are, it is also an very interesting space. They are also very heavily mathematics driven, but they help the governments and the banks to predict what will happen in the economy, right? When I say what is an economy, economy is who's going to produce, how much they are going to produce, how much are they going to sell, am I going to make profit or not at a company level, not at an individual level, but at a country level. How much GDP growth is going to happen. That is what an economist is going to come and tell us. And GDP growth will have a lot of parameters, including what would be my rains this year, what would be the kind of crop harvest that I would get, how much of industries that do I have, what percentage utilization they are working with, etc., and then they come up with GDP numbers. So that's one portion of what an economist does. He or she also will be thinking about policies on how to affect the general financial status of people. If the government comes and says that I'm going to tax all of you for 50%, whatever you buy, that's a way of controlling you to not buy stuff. If the government says that, whatever you buy, I'll put that money back into your bank, that's essentially government asking people to spend more money. So what are the levers and what will happen if those levers are activated is what the government does. You would have always heard about what is this USD versus INR, right? The conversion factor. Why is it 72 rupees? Is it 1 USD today is 72 rupees? Is it because Indian rupee doesn't have value? No, government can tomorrow come and say that 1 USD is equal to 1 INR. We can just go ahead and declare it. The moment you declare it, there's a lot of other things that will happen. India is dependent on a lot of exports, and other countries think that Indian products are cheaper because for $1 they'll get $72, 72 rupees of money. The moment this becomes equal, they did not come to India to buy stuff. They could buy it there itself, because for $1 whatever they get, yes, so whatever they get for $1 in their country, they will get the same in India also. They don't have to do all this. They don't have to buy from India. The moment they don't buy from India, people will not produce here, or the moment they don't produce, we will have huge unemployment, etc. So what, from that one decision that an economist is going to say, it is going to affect millions of people's lives and careers. So an economist is generally a very research oriented profession. It starts with mathematics, a lot of mathematics, and it's a very research oriented profession. Let's go to another data science. Interesting, right? Data science is anything with where you collect a lot of data and try to understand that data. For example, if I know that whenever there is huge amount of pollution in a particular village or in a city, right? We all live in cities, and whenever there is huge amount of pollution, the sales of air purifiers goes up. Now it is very simple. Oh, air quality is bad, so people are buying purifiers. What are the other things that are affecting purifier sales? How do I know about it? I need to go and find out whether people have money to buy it. If they don't have money, how do they buy it? Is it available in the market? Who's selling it? When I capture all this data, then I come up with models and say that, okay, you know what? If I want to sell more air purifiers, one, pollution levels should be very high, which I don't have any control of. What else should I do? Maybe I should give them some visibility. I tell them the benefits of air purifier, saying that you will have very less respiratory illness. How do I tell them that we will have less respiratory illness? I'll go to all the doctors in that area and collect data about how many respiratory illness cases do they see every day. Come up with some number, do some crunching on it, and then what now you have is the insight about pollution, illness, and then you have since it's a real insight, you can go and tell people that because of this, is because of this happens, and this is why you should buy this. So data science now just flowed into an application for selling air purifiers. Similarly, water. Similarly, any product in that for that matter, right? So in my profession, I have all these connected products spread across the world, and I try to take data from all of these machines, and then all of them come to me in a database, and then I start analyzing. All right, if it is a water purifier, for example, then I start thinking about, okay, if why people are drinking more water, for example. How do I make him drink more water? Is he drinking less water? Every single decision will come from analyzing that one bunch of data that I get from this millions of devices that I have around the world. Financial analysts, credits product officer, right? Credits product. What is credit? It's a loan. How do I go give loan to this guy? We have some risk rating. Again, if I give money to this guy, will he return it back? So we actually have a rating in our country, in most of the developed countries as well, called risk rating for a person. You go and say, I know I earn so much money, I spend so much money, I have so much of assets. Then I say that, okay, this guy is worthy enough, I can give him some money, and he's definitely going to give it back to me. So that is one kind of financial analysis that happens. Equity research, we look at stocks, we look at companies and say whether they are worthy enough to be invested or not. Will I buy an Infosys share at 10,000 rupees per share? Or when it is available at 1,000 rupees per share, is it a good investment to make? Will it go below 1,000 rupees, or will it go to 10,000 rupees? These kind of analysis is what we do. But the analysis is not done just on the numbers there. Two ways of doing it. You look at the stock prices historically and then predict it. Another way is what we call as the fundamentals. We go to the company, we see whether they are really making profit, how much they are spending, where are they spending that money, is it sustainable or not, etc., etc. So that's what an equity research analyst will do. An investment analysis, again, investing in startups. What is the value of a startup? You don't know. That guy has not made the product yet, he has not sold it into the market. Then I need to sit and figure out whether there's a market. Will people buy it? Will it grow? Will it grow to the extent that I can invest into it, etc., etc. So financial analysis is one of the again a very important role in today's economy, and people generally get into by doing mathematics or a CA certification, right? And the basis is BBA, as it's mentioned here. Yeah, we can go ahead. Mathematician. Cryptographer. So again, if you get into cryptography, right? Cryptography is just mathematics. It is about the probability of somebody breaking a key. So in crypto, what happens is that, you do some transformations. Very simple, 5 into 2 is 10. What else is 10? 2 into 5 is 10. I am not able to come up with anything else that will give me a value of 10. So when I'm sending this data over computer networks, I can send 5, 2, and at the end, on the other side, the guy can take it and multiply. I would have already told him to multiply, so you will say that, okay, 5, 2 is 10, or I can just send 10. And if somebody is going to be listening to that, what we call a sniffing in computer parlance, he will know that, okay, I'm sending a value of 10 to that other person. But if I send 5 and 2, there is also a mathematical transformation that needs to come in, and only me and the other person knows what would be the transformation. So what would be the transformation? It could be any arithmetic operator, or it could be any other mathematical function. So this is what a cryptographer essentially does. If I have to explain it very simply, there are complicated algorithms. We can talk about it, at some other point. But it is essentially understanding the transformations in mathematics. It has huge potential today in the computer world. And as I build a lot of connected products and deploy it across, one of the main things that I look at is how to protect these devices so that people don't read the data that is coming out of it. The moment they read the data, then it becomes a security vulnerability. You don't want people to read what these devices are sending, unwanted people to take that data, right? So that's very important. We can move on. Statistician, I think I spoke enough about statistics today. Can move ahead. We can, yeah. Astronomers, right? Astronomers is essentially calculus and algebra, and trigonometry, and so this is a very interesting provision, because here you're not talking about fancy transformations that I talk about in what you have in your real world here. We are talking about celestial objects, and you're talking about a different level of thinking. It is not even what we call as the Newtonian mathematics. We are here now talking about how to understand the interrelationships between numbers, essentially the positions of the planets, the speed, their velocity, and etc. How do I take them into different planes and understand them? Do I have to only look at them in a time series? Can I convert them into a frequency domain and look at it? By transforming them into different domains, I will be able to get different information out of these the data points that I get from the space. So this again is a very interesting space. But then the application of this is, if you land up as an astronomer, if you have a lot of interest in astronomy, you can reach out to a few organizations in this country, even otherwise, who work on the space in this area. This is again a very research-oriented profession. Universities, you can become professors in universities and continue your astronomical pursuits. It is a purely research-oriented job. Investment banker, I think I spoke about them a lot today. Or I spoke about, yes. Budget analysis is comes under economy. It is essentially accounting, right? So what happens here in budget analysis is, one thing is that you are going to forecast and predict. That is the simplest thing that you'll do in budget, but also you have to be extremely good in accounts. what get classified as where, where do I put my expenses, where do I look at for my revenues, and different, what are the different heads I will get it, etc., etc. So a budget coordinator is a very important person in a company, not so much in a stock environment, or in not as an equity research environment, or a investment banker environment. Budget analysts are usually working in companies which are well established, and there are huge large organizations. But this is something that we need to think, maybe in the next 10 years, yes, we will still need budget analysis, because this is all going to be automated. You don't have to apply a lot of brain into it. But the point is, as we go into the new era of companies, there is a new set of companies that are emerging these days in the Web 3.0. These companies are called distributed autonomous organizations, DAO. So these organizations will operate in a very different way from what we have in our current corporate or scheme of things. And there you will need analysts to understand how finances will be managed in these companies, how budgets will be managed in these companies, because they don't have hierarchy. They don't have even known people, but they will all be working together. They will be spread across the world. They will not know each other. There are no set rules. Then how do you manage the finances of that particular organization? That's when I say budget analyst, you should immediately start thinking about how it is applied in DAO. And that is where you will keep your edge and not become redundant. Let's go ahead. Survey researcher, again, there is a number of there are two ways of doing it, like, right? When you do research, one, you're collecting data. There are different types of surveys people do, but it all boils down to what is that, boils down to those mathematical principles to analyze, to arrive at results. For example, we do what is called as a principal component analysis in marketing. We want to know why somebody wants to buy a product. We go and do a survey. We say that, do you like the product? Do you like its color? Do you like its shape? Do you like what it does, etc., etc.? And then you have this bunch of parameters, right? Somebody will say that I bought that product because I like the color, or like the size, or the weight, or the sound it emitted, or etc. Then I need to understand what is more important to all these people. One guy will buy it because of one reason, another guy will buy it because of another reason, but what is that one particular reason why most of them buy? So we do what is called as principal component analysis. So collecting data, okay. Somebody's saying, can you explain how this is, right? So what we do is we assign weights to, say, each one of these parameters. One component is the color of the product. One component is the weight of the product. One component is the shape of the product. When I say 3 of them, and then I go and ask 100 people, each one will rate these 3 parameters accordingly. Somebody will say, on a scale of 7 or scale of 10, I like the color 7. It's more important to me, so I'll give it a rating of 7. The weight of the product is I'm least bothered about it, so I'll give it a rating 1. So if you go and ask 100 people, 1,000 people, then you have so much of data about these 3 parameters. Then you have to, the simplest thing that you will do is you just do a problem, you do an average of all of these and say that, on an average, people like the color of the object most, because the average is 7 for it, or 8 for it. And then people always rate weight as the lowest. So its rating is 2. So average is 2. Average rating for the weight is 2. So I don't have to worry about the weight. I'll only focus about the color. This is a simplistic way of telling, right? So this is market research also. So it's a simple way of telling that this is how people like the parameters of a product. Now it can become a little more complicated also when it is not just color. When the color is pink and the weight is light, then I like it. Then it becomes a little bit more complicated. And somebody would say that, in summers I like it. Color is pink, weight has to be low, and if it is summer, then I will buy a pink color product. Then the dimensions of my parameters become more complicated. That is when you apply principal component analysis. I don't want to get into the thing there, but that is when you say that, okay, then when you do this analysis, it will clearly come out and say people like the color most, weight the least, etc., etc. And then you, based on that, you create the product, or you strategize the product, right? So market research also is essentially the same, but then this is done in multiple region levels, what we call as dices, and we slice and dice the product sales, for example. Why do people buy? Have you ever noticed in any place when you go and get down in a bus stand early in the morning, you will always be able to get toothpaste. You will always get a brush in one of those small pawn shops or small kirana shops in the bus stand. Always, that's very rare that you will not get it. You will get that small sachet of coconut oil also, things like that. How is it possible that people know? You will say that, what, people when they get down in the bus stop, they will need these products, and hence it was stopped. But the companies who actually place those products there would have done amazing amount of analysis to identify how much of toothpaste will be required in each one of these shops. If I get down in Bangalore main bus stand, how much do I need? If I get down in a no named village, how much would I need? But it will be there. It will not be that suddenly 1,000 people land up in that place and this village doesn't have it. They will always be adequately staffed. How adequately they will have the adequate inventory? How? That is because they would have done so much of analysis to understand what is required where. That itself is a huge operational research problem, right? Management analysis, I could call myself one a few years back. We used to understand, do a lot of number crunching on the financial sheets of a company, profit and loss, and the balance sheets to understand whether the company is doing well or not. And in large organizations, this becomes very complicated to understand whether I have to put my money into marketing or into sales or into giving discounts to the customer, or just put the money and create more products. Just to take that decision, I need to know where are we heading to. And this is fairly simple. You understand a little bit of statistics and probability and elementary algebra, you will be able to sail through doing this, right? Let's go ahead. Cryptographer, one of the most complicated areas today, but it is not very complicated. It is very complicated in terms of mathematics, but people do achieve it. There are a lot of tools available, but the point is how to always ensure that there are no hackers around, there are no vulnerabilities around, and this complete area gave rise to a new field of cryptocurrencies also, right? So on one side, it is mathematics, which was primarily used for vulnerabilities and preventing security attacks and so on. But then people made a way to understand or transform them and apply them for currency transactions as well. It's essentially to end. So what they thought is like, how do I prevent people from cheating me online? So if I give money to someone, how do I make sure that everybody knows that I've given money to someone? If everybody knows, then this guy cannot say that I've not given it later. That is what a bank does essentially. If I give money to somebody through in cash, that guy can deny it. But if I give it through a bank, the bank has a transaction which is documented. What if the bank says that you never gave the money? That is when a cryptographer said, okay, instead of one bank, I'll have 10 banks, 10 registers where I will do it. So the cryptocurrencies came up from that concept. And today it is one of the most fastest growing financial domains, and one of the fastest growing job descriptions also. It's very interesting to be a cryptographer at this point of time. We can go ahead. Information research scientist, how to, so again, I said all this is being done by the computers, and the computers do not understand mathematics completely. You cannot use continuum, and they don't know the concept of infinity. They cannot crunch so much of numbers. So how do you make sure that your computer will process numbers without understanding the concept of infinity, right? So you have to find ways to make the processor do complex transactions with the least amount of energy consumption, if you have to say. So there are a number of ways of doing it. For example, if you convert your log 10 numbers into log 2, right? The base, if it is base 2, it all becomes zeros and ones, and the computer will understand only zeros and ones. So how do you make it process numbers faster? For example, 0 to 1. 0, 1 is 1 in base 10. 1, 0 is 2 in base 10, right? So just by shifting 1 from the 10 digits to 1 digit, what I've done is essentially divided that number by 2. 2 has become 1 now. So that's one simple thing. But in a computer space, there could be hundreds of other complex transactions you need to achieve. How do we do that? So that goes into a computer scientist role, and those algorithms that person develops will be implemented into semiconductors. Educators, again, if you need to understand, have a basic grasp of all concepts in mathematics to get here. Really, our teachers are one of the greatest human beings, because they understand all these basics, and then they introduce us to these areas. So with that, I think I would love to take questions. Arun, over to you.